So let's introduce an example on how to draw the shear and the bending moment diagrams. Sketch the shear and the bending moment diagram of this simple beam. The length is 2 meters and it has a distributed load of 500 Newton per meter. Firstly, we have to find all what we know from statics. The statics tells us that Ra equals to Rb equals to 500 Newton. It is very significant because it is distributed load across the whole length. Now we cut the beam at an arbitrary location x. Then we consider the forces on this tiny section. First, Ra equals to 500 newtons. Besides, there is a distributed load 500 Newton per meter for a length of x. So this length is x. Now we are going to find the equation of shear force and moment on this end. Still recall our sign convention. You cut this section here and you have this left section and the right section, which is not drawn in this problem. For the left section, on its right hand side, the sign convention of shear force and moment is like this. For moment, you are bending it to smile, or for shear force, you are pointing downward. Then you can find the equation of shear force and moment in terms of x. For the shear force, by the force equilibrium, the forces in the vertical direction is 0, means that Vx plus 500 Newton per meter times x meter minus Ra equals to 0. Consequently, we can write Vx equals to Ra minus 500 Newton per meter times x meter. Then Vx equals to 500 minus 500x. Next, let's consider the moment in this beam. For this piece of cut material, the distributed load has a moment center located in the midway. The magnitude is 500x. Now we take the moment from this end. Then Ra is generating a moment of Ra times x, while the distributed load will generate a moment of 500x times x divided by 2 in the opposite direction. Then we can write mx equals to Rax minus 500x, which is the magnitude of the distributed load, times x divided by 2. Now we have both Vx and mx. Then we simplify them to get this result. Next, we can draw our shear and the bending moment diagrams by using those two equations. So for this equation, it is linear. At x equals to 0, it is 500. At x equals to 2, it is minus 500. Then you can just draw this straight line like this to get this shear force diagram. Besides, the moment is actually a quadratic equation. Recall that the axis of symmetry of a parabola is given by minus b divided by 2a, which equals to minus 500 divided by minus 500 equals to 1. So the axis of symmetry of the moment is located at x equals to 1. Then we just draw it like this, then it is done.